All right, so here what we're supposed to do is we're supposed to be looking at how this factory produces carbon emissions from a plant, and it plants 22 hectares of a forest in 1990. The trees absorb the carbon dioxide as they grow, thus reducing the carbon level in the atmosphere. Now, the EPA requires the trees to absorb as much carbon in 20 years as the factory produces during that time. Now, the trees absorb no carbon until they're 5 years old, and then between 5 and 20, the trees absorb the carbon at the rate indicated in the table. All right, so first find a model for the rate of change of data, then construct a model giving the rate of change of carbon absorption for the 22 hectares. So notice this change is per 1 hectare. So that means we're going to multiply by a factor once we get to that second part. So let's start with that. And so I plotted the data, and it kind of has this shape here. You know, there's some curvature to it. Since a lot of this data seems to be quadratic, they've been giving us, I'm going to try a quadratic to start with. And so we'll go down here, plug in that far as 1. All right, so that looks pretty good as far as the curve goes. It looks like it fits pretty well. So let's start with that. And so our first part, A, looks like we have let's call it R of t equals, it was 0.022 t squared plus 0.918 t, and then it was minus 5.05, and that was tons per hectare per year. Okay, and again, that's just our units here. So now we're supposed to find a model of carbon absorption. So between 0 and 5, there was none. So what we can do is, let's say we have an f of x equals, and we have 0 is going to be from when 0 is less than or equal to x less than, not equal to, just less than there. Let's just put less than. Less than 5. And then otherwise it's going to be this equation per hectare. But remember, we've got 22 hectares. So this is going to be 22 times R of t. And that's when 5 less than or equal to x less than or equal to 20. Okay, so that's going to be our function with that. So that helps us get part A. Now, part B, what we have to do is we have to plot basically, well, 0 is just going to be a flat line. And then 22 times RT, we're going to have a curve that's like that, but it's 22 times larger. And then we also have to plot from 1990 to 1997, it was 246 tons. So we'll have a horizontal line at 246. And then from 1997 to basically 2010, it's going to be 190 tons. So there's going to be a horizontal line at that point. So let's go see what we can put in our calculator. And so let's insert and say 22 times that. And then we can put our in parentheses at the end here. We're going to have something at 246 and 190. Now our window's not going to be right because we're going up so high. So let's go to 250 and let's go by 50s. Our max window should be okay because we're still going out to 20 years. So that should be good. Now, note we're not following this here curve anymore because we're going 22 times it. So it's going to look something like that. All right, so let's draw that. So it's going to be this one up to basically our 246 to 7. And then from 7 on out, it's going to be this one. So we don't have to worry about this intersection, but we do have to worry about that one. So let's find that intersection. Red, what did I hit? Yeah, I want blue, black. All right, so that's 11.654 and 190. So I think we have enough. We can start drawing a picture anyway. So let's do this. So at 5, it looked like it went up like this. And then we had a 246 and we had a 190. Again, we're just sketching. We're not being precise here. So 246, if that was about the 5, we'll call that maybe here about 7. So we'll go up to about that point. And then it went to 190 after that. So then it went from here out to here. Now this curve keeps going up, but we're not able to show all that here as far as because it's going to keep going out. But so this is our 22 times r of t. This is our 190 that's at. And so now what we need to think about is, oh yeah, we wrote the label here. What was that? That was 11.654, I think, and 190. And so I think that's our label for part B. I think that's everything we need. And remember, it was 0 down here. So you won't be able to do that. And me drawing over a line is going to make it look like it actually was a value. So that's all we had to do there, I think. So now we're at part C. Label the regions in the graph of part B whose area corresponds to the following quantities and calculate their values. All right, so let's see here. I think probably best to draw another graph here. So and again, we're just kind of rough sketch it in here. All right, so the carbon emissions produced by the factory but not absorbed by the tree. Well, that's going to be anything above our lines. So if we maybe kind of do this one in red, it's going to be everything from here down to here, over to here, and following that. So that whole area is going to be part 1. So this is called this region 1, and this is kind of our I. Okay. Now the key thing is here, we have 2 pieces. We have, this is kind of a region 1 of R1, and this is a region 2 of R1, because here it's under this curve that we can calculate, and this one is under this curve that we can calculate. So we're going to have 2 calculations here. Now let's do a different color. Let's do, I don't know, green. So now we're going to do produced by the factory and absorbed by the trees. All right, so that's going to be, you know, here they're producing it, and we're going to be everything, and you know it's going to go out, and this is, let's call that 20. We can't show it on our graph, but that's going to be. Now key here is this region is going to be under this curve. This region is going to be under this curve. So this is overall is going to be region 2, and it's going to be our I. And so, but we have a part here, and we'll have a part here. Okay, so thinking about that's under this curve versus under that curve. Now we have region 3, the carbon absorbed by the trees from sources other than the factory. Well, let's make that one, I don't know, black here. And so it's going to be basically, you know, everything here. So this is region 3, and this is what they asked for I. Okay, and it's going to go, you know, that's going to go way up high, and so we'll have whatever's under that curve but above this curve. So take that one minus that one. All right, so I think that's all of our regions. Now, what we need to do is we also have to calculate their values. So I think what we're going to have to do is go to another page and start writing those down. Hopefully I have another blank page. All right. Let's look at region 1, and we have part 1 and part 2. So region 1, part 1 is going to be the area under the curve of the 246. And then region 2 is going to be the area under 190. But it's also, I guess we should probably, yeah, let's see. Okay, so I think we actually need another region here, because remember, this was starting at 5. So even though we said, you know, it goes over here, I hadn't thought about that, because this, when we subtract, we're going to have a third region. So we're going to have one just from this down to basically our 0. And then we'll have this one down to our graph here from basically the 5 up to 7. And then this one from here to the graph from 7 to, and that was our intersection of 11.654. So there's going to be 3 pieces here. So I hadn't thought about that, but that's really how it needs to be. So let's go over here. And so now our three pieces. So this is region 1, and we'll do part 1. So that's going to be from 0 to 5 of 246 dx. Okay, well, basically, what is that going to be? Well, that's going to be 246 times 5. Okay, because we're going to put it in, it's going to come out as 246x, and we're going to go from 5, which is 246 times 5, minus 246 times 0, which is 0. And so this is 1230, and our units are tons. Okay, so tons. Then we have our region 2. That's going to be, we said because of this, basically our 7 until 11.654. So it's going to go from 7 to 11.654. And that one's going to be our 190, which is higher, minus our f of x. And we'll just put it all in once so we don't have to do it twice. And so that's going to be dx. And so that's going to give us, and let's go look in our calculator. And so let's clear that. So we're going to do math, and we're going to do, let's see, 9, and we're going to go from 7 up to the 11.654, and that's going to be the 190 minus, and I think I hopefully have it here in y1, but now I don't want, yeah, I do want that one still. And so let's go back here. And so we want it to y1, and then our x here. Okay, so that's going to give us 324.634. All right, 324.364. And then our part 3, that was from 5 to 7. And that was for the 246 minus our f of x dx. And so this piece is going to be, and now we're going to go, let's do the second inner, and here we're going to go, oops, 5 up here to, now that's 7, and now instead of 190, it's 246. Oh, forgot the 1 delete. And now we have to add a y1, subtract it off. And so that's 436.677, 436.677. And so the total of that region is going to be what? Well, I'm just going to do it in my calculator here. 123 plus 324.634 plus 436.677 equals 1991.311, and that's tons. Okay. So that is going to be our region 1. So that's the region red. Now let's do region 2. So we're here, we're going to go from our graph to 0, and then from that graph to 0. So region 2, we're going to have region 1, it's going to go from, and that's going from, that was equal to 5 up to our 11.654. Oops, wrong direction. So we have 5 to 11.654, and that was just our f of x and dx. And so we'll write this down, and then we'll come back and we'll actually calculate it. And so the next one was for the 190. So it's going to go from, oops, can't write here. So it's going to go from, won't erase either, but that's beside the point. 11.654 up to 20, and that's of 190 dx. So we have to write those two in. So first off, we're going from math 9, 5 to 11.654 of our alpha 1 of x. So 614.949. And then our other one was the same. Oh, no, it was from here. It was from math 9. It was going from the 11.654 up to our 20 of our just our 190. And then our x. And so that's 1585.74. So 614.949. So we have 614.949 and then our 1585.74. And we add those two together, which I'll just do on my calculator, 614.949 plus 1585.74. And it says 2200.689 tons. And then we have R3 now. Now R3 is basically between 11.654 and 20, and we're going to take f of x. Yeah, so f of x minus, okay, so let's go put that in our calculator or write it down. All right, so we're going to go from 11.654 up to 20, and here we're taking our f of x minus our 190 d of x. And so if we do that in a calculator, math 9, 11.654 up to 20, and alpha trace 1 minus our 190, and then that's an x. And so it looks like we get 1190.061. So that's 1190.6 or 061, sorry, 061 tons. And so now what we have to do is we have to figure out the produced minus our absorbed. All right, so produced and absorbed. Right. So after 20 years, so absorbing or producing, so 246 tons between there and there, and 190 tons between there and there. So that was our basically our 1191. So we're going to take 1991.311 minus, and here what we have is there between least much. All right, so then we have to subtract off the part up here because that's going to give us that. That is going to be the amount absorbed. This is amount produced. This here already takes into consideration this part. So this is all taken care of. So all we have to worry about is R1 and R3. So we're taking 1991.331 minus our 1190.061. And that gives us 1991.311 minus 1190.061, 801.25 tons, and that's in excess. So more produced than absorbed. Okay, so there's too much there, and so basically they're not meeting their requirements. And so after the 20 years, that's not the case. So this area is a lot bigger than this area here. So, you know, this area is all absorbed, this under the curve here, but the red versus the black, that's not the same. So red's bigger than our black. And so they're in trouble. They don't have enough with the 22 hectares of trees that they planted. All right, so that's all I have. So hopefully that helps.